Hello, everyone, and welcome to the Kalamazoo Astronomical Society's online viewing session for February 12th, 2023. It is great to see you all here on Super Bowl Sunday. Obviously, you either don't care a rip about the Super Bowl or football in general, or you're multitasking tonight. You're watching the online viewing session and the Super Bowl at the same time. Maybe you got eyes going in different directions there. But either way, it is great to have you all here. Apologies for having to postpone one day, but if you did look at the all-sky camera that I'll show you shortly around start time yesterday and for maybe an hour or two afterwards, it was a complete shutout. It was completely overcast. So there's no way we could have had an online viewing session yesterday. So the one thing we absolutely cannot control is the weather. Trust me, we've tried. We've sacrificed many amateur astronomer. It doesn't do any good. So we just can't control the weather. And that goes for tonight, too. It is crystal clear. But the one issue we might have a little problem with is the wind. We're fighting the wind out there all the time. Normally, we have a alarm go off if the wind hits 10 miles per hour, and then everything shuts down and closes up. But I sort of disabled that because currently the wind's about 7.1 miles per hour. It was nearly 10 earlier. So hopefully it'll die down. It won't affect the first telescope too much, but it might affect the bigger one later. That's the one that really kind of wreaks havoc on. All right, so let me go back to sharing the screen here and let's get started. So here you can see our little startup slide here. I always try to have a different picture here. I only really have 4 that I circulate. And so this is the one that Mike Patton took for me. This is the observatory the telescope is located in at sunrise. And of course, you can see it fairly clearly here. But here it is, of course, during the day with the roof rolled off. So yes, this is owned by Kalamazoo Astronomical Society member Mike Patton. And this is a 20 by 20 roll-off roof observatory. So obviously the roof could roll on and off to expose the telescope and other equipment inside to the sky above. And just over here, you can see the old telescope peeking upward there. In fact, I should turn on the old laser pointer there, and there we go. So you can see the telescope there. This is a 20-inch, and you can just see the Takahashi right there. And we have a weather station. And this little gadget right here that I'll show you close up. So this is the S-Big All-Sky 340C color camera. And it basically has a fisheye lens and shows us the entire sky. So we could technically, or theoretically, use this camera to, look for meteors. But it only it takes a picture like every 4 minutes or so. So it's mainly used just to kind of check the weather above Arizona Sky Village and just see what's going on. But we'll kind of check back with the all-sky camera here from time to time, because who knows, maybe a bright meteor will streak across the sky. I did see some news that there's a 1-meter asteroid expected to burn up over like northern France. So I wish we were there because we don't get to see any of that. That would look pretty good on the all-sky camera. So let's go ahead and switch to the camera. And let's check out the weather above Arizona Sky Village, home of the KAS Remote Telescope. So there we are. We always get this kind of brownish tinge when the sky first grows dark. It'll get blacker later. I think it's mainly through sunlight during the day, kind of maybe bleaching out the chip a little bit. And so basically toward the top here is north. In fact, probably this star right here is the North Star. So we do kind of lose a bit, little more of the northern horizon than the southern horizon there. And later on, when we check back to the all-sky camera, we should be able to see the Big Dipper come into view. So again, this is north. Down here is south. This is our bird perch that you can see here. That keeps birds on the perch as opposed to the dome here and leaving bird droppings behind. And so over here is west on the right, and east is on the left. And this little funky structure here looks like some kind of UFO or something like that. But nope, that is the roof to the observatory open, which it looks a little illuminated. So I hope Mike doesn't have any pesky lights on inside. It looked dark in the camera, in the webcam inside that I'll show you later. And oh darn, we just lost it. I was too slow. But just now setting behind the mountains between the last exposure, because you just saw the page reload, and there was a little dot here that just disappeared. That was the planet Venus. So we just lost the planet Venus, which is now in the past month or two re-entered the evening sky to become the evening star. And here we have Jupiter, and another planet is Mars up here. Now, our setup is not designed to look at planets, so we won't really be checking out Jupiter. We'll try to get Mars, but a wide field shot where you really can't see any features, because there's a little fuzzball kind of right around here somewhere near Mars that we're going to try to capture, but it's going to be tough tonight compared to yesterday. It would have been easier yesterday, but it's going to be tough tonight because the little sucker is just moving pretty fast. And you can see kind of a glow here, which looks like light pollution, but there is very little light pollution from Arizona Sky Village. There's a few small light domes here and there. They look much worse in the 1 minute exposure here than they really are there in person. But this shaft is called the zodiacal light. It's basically dust in the plane of the solar system reflecting sunlight. And it's long been taught by many instructors and professors like me, an instructor, not a professor, that this is basically from, comet dust and asteroid dust. But there's new evidence to suggest the zodiacal light may actually be dust from Mars. Whether or not that's true, or, as usual, it could be just a combination of several factors, asteroids, comets, maybe a bit from Mars. But anyway, we do know this is dust in the plane of our solar system reflecting dust. And of course, you can check out the all-sky camera for yourself every night. Let me scroll up here. And you can go to our website. Of course, the menu here is the same on pretty much every page. Go to Remote Telescope and you can pull up the all-sky camera yourself. You can do that now or do it any other night of the year except the summer, because we do shut down the telescope from July to the end of September because of monsoon season, and we don't have any kind of insurance for the telescope because it's on someone else's property. So if lightning from the monsoon fries the telescope, well, that's pretty much it. We're done. So that's why we unplug everything over the summer. Plus, we're all too busy going outside to observe under the sky anyway, instead of using the telescope remotely. So let's take a quick tour of the constellations, and then we'll start checking out stuff with the telescopes. Obviously, what dominates the sky is Orion the Hunter, my favorite constellation, probably the most identifiable constellation in the entire sky. Of course, the Big Dipper is not a constellation. It's part of Ursa Major, the Great Bear. So Orion's #1 in my book. And Orion's probably the most famous because it has a recognizable pattern. You can say 3 stars in a row, 2 above and 2 below. Of course, the 3 stars in a row are his famous belt, Orion's belt. The 2 stars above are his shoulders, with Betelgeuse marking the right shoulder. Technically, Betelgeuse or Betelgeuse means armpit of the Great One. So this is technically his armpit. And then we have Bellatrix, and then his feet, Rigel and Saiph. And hanging from the belt, of course, is a sword. And we're going to look at an object tonight in the sword, but it is not the Orion Nebula. We did that last month. And even though the Orion Nebula is super cool, we try not to do it every month. So just above his shoulders, of course, is his little tiny head. It's like a small cluster. I'm not sure if it's technically a cluster. You can fact check me on that later. But memory fails me there. But he has a little tiny kind of triangular head there. You can just make out his shield here, and he's holding up a club that goes up to these 2 stars here. Of course, he's holding the shield because if we use the belt stars and go up and to the right, it leads us to the eye of Taurus the Bull, Aldebaran. And so this is the eye, and this V-shaped cluster, which is an open cluster, represents his face. And this is called the Hyades. So Aldebaran here, though, is much closer than the Hyades. So this is not a true member of the cluster. Or is it vice versa? Or is the Hyades closer? You know, it's one of those. The Hyades is definitely not part of Aldebaran or vice versa. And then on the back of the bowl is the Pleiades, which we did check out last month with the Takahashi. And then we can go up from Aldebaran, or we can say from Rigel to Aldebaran to Capella, which is the bright star in this house-shaped constellation called Auriga the Charioteer. And there's some nebulosity here, but lots of nice open clusters too, which we have checked out before, but I don't believe we're doing anything in Auriga tonight. Then we go down from Capella to Castor and Pollux, which are the Gemini twins, Castor and Pollux. And you can kind of make out the stick figures here. There's like a little short neck here, long neck here with a body and little stick legs with like a little arm here and a little arm here. And they're kind of holding hands. So here's the other brother's head, Pollux, with little short arms, a little short body, and these long bull legs. Or you can just kind of draw it into a little rectangular box here if you like to make life a little easier on yourself. So now we go from Pollux, which is technically the corner of the hexagon, down to Procyon, which is just two stars that form Canis Minor, the little dog. And then we end at Sirius, the brightest star in the night sky, which is also known as the dog star. And we're going to look at a cluster that you can just barely make out right there later. So the dog has like a triangular head, a little leg there, a long body, a little leg here, and a little tail. You can give him a long tail too. Sometimes I give him a curly tail after a husky I used to have, but it's a little stick dog there in the sky. And of course, inside the hexagon is Betelgeuse, armpit of the Great One. And we are getting into spring now. You can just see the sickle. This backward question mark is an asterism called the sickle, and this represents the mane and head of Leo the lion, with the bright star Regulus representing the heart of the lion. And lastly, we do have Cassiopeia up here as well, which is, I think, technically a spring constellation because it's highest in the spring. It's circumpolar, so we see it all year long, at least from Kalamazoo. It's circumpolar, so it never rises or sets. But it's highest in the spring, so we can call it a spring constellation. So it's still February, but the fact that Cassiopeia is getting higher, Leo's becoming visible in the evening, that tells us that spring is on the way. Thank goodness. And there goes the camera reloading again. We can see some clouds here, but hopefully they'll stay away. We're supposed to have at least a couple of hours of good, reliable, clear skies. It's just the wind is currently 9.5 miles per hour. Yikes. So that's a little higher than we prefer. But again, hey, beggars can't be choosers, right? Okay. So we're going to start, as always, with our Takahashi refractor. And I don't believe he signed on with us tonight, but I want to thank Mike Patton for recently taking some new pictures of the telescope because, as I mentioned last month, we have a new addition to the Takahashi. This is our Moonlight Nightcrawler 2 focuser right here, this beautiful red thing. So we replaced the stock focuser with this focuser because it can hold up to 25 pounds. And our big camera and filter wheel, that weighs a little over 12 pounds, and it was a little taxing on the original focuser. So that's why we did this major upgrade with this really high-end Moonlight Nightcrawler 2 focuser. And of course, this is our Takahashi refractor, which is about 4.2 inches in diameter, which means it has a 4.2-inch lens up front, or really lenses. Every refractor has at least 2 or more lenses. Some have as many as 5, but most have 3 or 4. This one, in fact, has 4. So we use this telescope for wider field views, things the other telescope really can't look at because they're just too big to really fit in the entire thing. And I mentioned the camera, And it's kind of old school now, but this is our SBIG STX 16803 CCD camera. So CCDs are on the way out. They're being replaced with CMOS cameras because they're cheaper to build, and they do have some other advantages. The noise tends to be a bit better, but this is a really a high-end camera. It's full frame with a nearly 37 millimeter square chip. And, you know, by today's standards, about 17 megapixels here is getting to be a little on the low end, but we only have DSL internet out there. So every time it takes a picture, it has to upload it to our cloud account. And, you know, that tends to take a couple of minutes out there. So we're in no hurry to get a really high resolution camera because it would take forever to upload the pictures. So here's our very first target of the night. We're going to go to IC 1805, which is known as the Heart Nebula. So before we do that, I have to go back to the browser and let me introduce you to this screen here. So this is the web interface for a program called ACP, or the Astronomer's Control Panel. And this is what we use to control the telescope remotely, because we don't give members access to the actual computer at the observatory, but this feature here, this web interface, basically allows you to control the telescope from anywhere in the world with a high-speed internet connection. But, you know, don't try to type in this link here because you got to have a username and password, and, you know, I'm not sharing mine. Before I go to our first target, I wanted to show you one thing from the telescope late last night, or really very early this morning, Michigan time, because even though it was cloudy last night, it was clear here. So I did go out and do some observing and imaging on my own. But once I got back, I checked the all-sky camera. It was kind of starting to clear a little bit. So I figured, why not try to snap an image of Mars and the comet when they were pretty close together? So I did. It's a little hazy because some clouds did go by during the exposure. So, of course, this dazzling bright thing here is Mars, and you can't even fit the whole thing in here anymore. And there's the comet down there. Now, of course, tonight they're further apart. Technically, I think we can get the comet like down here and Mars up here in the other corner if the camera is oriented correctly. Even though it's a square chip, it does make a difference because they are so far apart compared to last night. But we're going to try to get both Mars and the comet again, but I kind of think we're going to crash and burn there. So I wanted to show this to you here. And this will be one of the images that you'll be able to download tomorrow. I will include this image from last night with the download of the images we collect tonight. And this is just a single 3-minute exposure with the Takahashi. Okay, so let me scroll down here, and you can see I already have IC 1805 entered in. I did hit get coordinates because I've been guilty of forgetting to do that. And we're going to do a 10-minute exposure because it looks pretty sweet at 10 minutes with what's called our hydrogen alpha filter. So we're going to go ahead and hit acquire image and let that begin to do its thing. So in the background here, it's going to prepare a program called MaximDL to control the camera. It's also going to control what we call an auto guider to guide the image because no telescope mount is perfect. So all kinds of stuff goes on in the background while we're taking this picture. So while we're doing that, let me introduce you to our target again. So we're looking at IC 1805, the Heart Nebula. This was discovered by William Herschel, very famous German turned English astronomer. He discovered Uranus, which made him very famous. But he discovered this target on November 3rd, 1787. And it's classified as an open cluster. IC 1805 is actually the open cluster, but that designation is also associated with the diffuse emission nebula, which is the Heart Nebula, which is formally cataloged as Westerhout 4, which is a catalog of nebulous objects. And it's also cataloged as Sharpless 2-190. And of course, the name describes how the nebula looks in wide field images only, not visually. And it's also known as the running dog nebula because that's how it does look when it's viewed through large telescopes. So technically you could view this one with a telescope, but you got to have a pretty good sized telescope and dark skies to really bring it out to see the running man. But it only gets its name, the Heart Nebula, from images. And as always, if you're joining us for the first time, I always show a sketch here from an amateur astronomer. So this is how it would appear through a large telescope under dark skies visually. So sketching's really great because it helps your eye, it trains your eye to see more information as well. So you can see some basic facts here as well. You know, I just put the right ascension declination here for giggles. Everything's built into the computer out west, so we don't really need to know this to find it. And the nebula itself is quoted as magnitude 18.3, but boy, that seems way too low to me. But many sources say the same thing, but I suspect they get their sources from the same place. And it's pretty good size. 150 by 150 arc minutes. You know, for comparison, the full moon is 30 arc minutes. So that's why we're using the Takahashi. This thing is big. And you can see it's about 7,500 light years away in the constellation Cassiopeia. It's kind of near the border, sort of Camelopardalis, the Draft, but it's technically a little across the border into the constellation Cassiopeia. This chart here shows Cassiopeia a little higher than it is. So this is a bit later in the night, but it's fairly accurate, you know, for almost where we're at right now. So this is a rough view of where we see it in the sky. But it's located 5 degrees east-southeast of Epsilon Cassiopeiae, which is right here. This is the kind of one end of the W there. And so it's just 5 degrees east-southeast, or it's about 4.6 degrees north-northeast of the famous double cluster, which we have looked at before with the Takahashi, but we're not doing the double cluster tonight. But there it is. I think the actual a sketch here of it on the Sky Atlas looks more like an actual heart than the Heart Nebula. You know, the Heart Nebula looks like your typical drawing of a heart, but this has a more realistic view here. And of course, IC 1805, or of course, Westerhout 4 is close to Westerhout 5, or IC 1848, the Sol Nebula. And that's only 2.5 degrees to the southwest. And of course, together, these two form a famous pair called the Heart and Soul. And we've done the Sol Nebula before as well. This isn't our first time doing this target, but every time people see a picture of the Sol Nebula for the first time, they all say it looks like a fetus, because yes, it looks like a fetus. All right, so let's switch back to the browser real quick and see how we're doing. We successfully located the guide star. Now the trick is, can we keep it? Because the current wind is about 11.6. Oh, nope, sorry, 11.5 miles per hour. The guide star looks like it's doing very well, but you can see it's a little choppy, and that is caused by the wind. So hopefully the wind won't get too strong and we lose our guide star. So I'm going to keep an eye on that. So we're a little past a minute into our first exposure. Now, let me go into the participant list here and allow you to unmute yourself. So we have some time to kill here. So let me stop sharing the screen. So everyone's welcome to unmute themselves. If you have any questions or comments, now's the time to ask, or you can just—
Hello, Richard. How are you doing?
Say hi and introduce yourself. Welcome. Hi.
How are you?
I'm great.
Houston.
All right. How's the skies down there?
Clear. I saw it yesterday at the George Observatory.
It is actually clear here too again, so I'm sacrificing local clear time for you folks. Otherwise, I would be out there. It's very rare for us to get clear skies in February. Please talk football elsewhere. I'm here for astronomy. Uh-oh. Oh yeah, people are talking about football. Oh, Jeff, what are you doing talking about the score there? I do believe Jeff told me he didn't care about football, but he's sure on the score. That's okay, Jeff. We don't mind. Just do it in the chat. Anybody have any other questions or comments? We certainly have some time to kill.
When you're taking this picture, Richard,
yeah,
what would be an equivalent ISO for what you're using there, the equipment? Do you have any idea?
We are doing this is a CCD camera, so we're using 1x1 binning, which gives you the maximum resolution of the camera. There's no gain with CCD cameras.
Okay.
Unlike CMOS cameras, because with CMOS cameras you have gain. With digital SLR cameras or mirrorless cameras, you have ISO. Gain, ISO are the same thing, but that doesn't quite work out with CCD cameras.
Okay.
So, but if you did want to take a picture of this with a DSLR, the recommended ISO is always 1600. It's not too low to where it's not terribly sensitive or too high to where it's going to be really noisy. So with a DSLR or mirrorless camera, 1600, but with the gain for your CMOS cooled camera, it depends on the specific camera. It varies from model to model.
Why is it green in color?
I'm sorry?
Why is the comet green in color? What's the explanation for that?
Oh, the green for the comet?
Yeah.
That's caused by something called diatomic carbon, basically a doubly ionized carbon. And it's very common in comets. The media went crazy with this comet for some reason, just calling it the green comet. You keep hearing that over and over again, the green comet, the green comet. People have been emailing us, when can I come out to see the green comet? And I keep telling them, it ain't going to look green. That only comes through during exposures.
Okay.
Visually, it's going to look like pearl gray, like everything else in the sky.
Okay.
We'll accept stars and planets and some planetary nebulae that you can see color in. So hardly anything we can see has color. Yeah.
They keep calling it the green comet because its real name is not very catchy.
That's probably a big part of it. You can't call it the C2022 E3 ZTF the whole time.
No.
But you can call it ZTF. That's kind of zippy. Or just name it, just call it the Zwicky Comet, because the ZTF stands for the Zwicky Transit Facility, because it's named after a astrophysicist named Fritz Zwicky. So you can call it Comet Zwicky.
But then if that facility keeps finding comets, then they're all going to be named that.
Yeah, that's what the E3 is about. That part changes, and of course the year changes depending on what year.
There needs to be a system like that for hurricanes where they get a person name.
Yeah.
I did show the comet to a bunch of people last night. That my wife's involved in scrapbooking. When I picked her up, I showed them the comet with my 10-inch telescope.
Oh, great. Okay, I did see one question in the chat. The image of the comet and Mars that I showed, that was taken with the Takahashi at about 1 o'clock this morning. When I got home, I checked the all sky camera. It was kind of clearing out, but not 100%. And I figured I'll fire it up real quick, take a shot, because I knew tonight they're probably going to be too far apart for us to get individually.
Maybe we can figure out a name for the comet by the time it comes around again.
There you go. I think Comet Bell's pretty snappy. I like that. All right, let's go. Let's check back and see how we're doing. I should be watching the guide star. We're doing good still, but boy, that's really seesawy. It's supposed to be a relatively flat curve with a few bumps here and there. Not this chart that looks like you're having a heart attack. So that's a sign of the wind. But I can give you an additional weather report. Let's see. Again, we're at 9.2 miles per hour. The ambient temperature is 62.6 degrees, and the humidity is 16%. That is disgusting. It never gets that low in Michigan. It was down to the mid 50s for humidity last night, and that's good for us. So that's terrible. And you can see it goes through a whole set of configurations to try to find a guide star. And it had a little trouble, it looks like this time, but it eventually got one. So that's what's great about this program, is it really works for you. And you can see a bunch of other gibberish here. We won't look at the whole thing. You can see it's measured the true focal length of the Takahashi. So 530.9. But there we go. So we're getting there.
Seeing, waiting.
Not every exposure will be 10 minutes, but I try to. But with hydrogen alpha, you tend to want to go a little bit longer. Plus, it's going to look pretty awesome. Oh, and I have not done this yet. I forgot. So let me go, while we're waiting, we still got a little bit of time. Let me go to the all-sky camera. Let me hit reload here, because the video always freezes up if I go to another screen. Now we see the matrix view. So this is our Piishi observatory webcam. This is a webcam we have in the observatory, and this is a live view of the telescope. So you can see stuff zipping by like crazy. So that's a sign that it is windy. So here's the Takahashi with the moonlight focuser and our STX 16803 CCD camera. And of course, later on, we'll be using the big scope, the 20-inch plane wave. So you can see we're looking this way. You can see the mountain that's kind of pointing this way. This is north. So we're kind of looking high in the northwest here, way up there. All right, we got to be getting close there. So let's go back. And of course, as always, when I share the image, please unmute yourself, because I like to get your initial reactions recorded. I don't want to say on tape, because we're not using tape anymore. This is all digital. All right. So the 10 minutes is complete, but what'll happen is the image will download from the camera. Maxim will do a little bit of processing of the image. It'll stretch it out a little bit, and then it'll create like a little thumbnail, and the thumbnail is what we will see here. But when you get to download these pictures later, you will get to download the high resolution version. Ooh, that looks a little glowy. I wonder if there's high level clouds or something. All right. All right, you can hear those little bonk bonks, and we get the little note here. So are we ready? Here we go. Yeah. First image of the night. There it is.
Oh, wow.
Oh, nice.
Fabulous.
The Heart Nebula.
Great.
Looks like a heart kind of.
So there you go, the Heart Nebula.
Huh. So what color would it normally be?
It would be very red.
Very red, okay.
Yep. All right, so a few technical figures here. The Heart Nebula is located in the Perseus arm of the Milky Way galaxy. That is not the arm that we are in. We are in a little spur arm called the Orion arm. And if its distance of about 7,500 light years is correct, that means this nebula has a true diameter of about 330 light years. So 330 light years across. That's big. The brightest part of the nebula, which is this part right here, this kind of knot at its western edge, is separately classified as NGC 896 because it was the first part of the nebula to be discovered, again, by William Herschel. So this is the easy part to see. And there's a small open cluster known as Malo 15 that illuminates the nebula. You can see some of the stars in here, but hydrogen alpha tends to dampen down the stars a little bit and bring out the nebula, which is why I use the hydrogen alpha filter in the first place. So Malo 15, you can see some of the members here. That's a loose collection of about 60 visible stars in a region about 20 arc seconds across. So again, a bit smaller than the moon. The cluster contains very young, hot blue, hot supergiant stars about 1.5 million years old, which is to be expected in a nebula like this, because those big, hot blue stars will probably never make it out of the nebula. They might go supernova before they ever even leave it and try to travel through the galaxy. So I did mention it is possible to see this in a telescope, but in a 12 to 14 inch telescope with a UHC filter, kind of a broadband filter to bring out the nebula, it is very faint. The most obvious part is a dim 30 arc minute long streamer south of Malo 15, which it would take us forever to sort out in this picture here where that is. But in a 16 or 18 inch scope, it's an extensive circular hazy glow. So there you go. So yep, we do call this an emission nebula, but you can also refer to it as a stellar nursery. All the stars here in that cluster and around are all relatively young. 1.5 million years old is pretty old for these stars, but compared to the sun at over 4.5 billion years old, these are babies. So they're babies still in their nursery in the process of forming. And some are so big, they'll die there. They'll never make it out of the nursery, which is kind of sad. So there you go. There's our first target of the night. IC 1805, the Heart Nebula. So we'll go ahead and close the view here. And we're going to go to our next target. But before we do,
Richard, I have a question,
yes.
if you don't mind.
Oh yes, please.
When you just showed the top of that photo, and it did not have that nebulosity in it. Is that true, or is that due to the photography?
No, that should be true. That's pretty much the extent of it that we saw there in the center.
Okay, yeah. I was just wondering, because sometimes I know on the edges of the photographs, the funny things happen.
Okay, so let's try to go to our next target. Now, I probably should have wrote this down, but I'm gonna do the best I can here because I wanted to get a up-to-date view of this. We're going to try to do now the comet and Mars. Of course, I showed you a view of it earlier from last night, but I wanted to get it live. So let me type this in here. I can't use the slash because it will not like that. And I got to type in this whole thing here so it goes into the right folder, so I can find it later. And I'm gonna start off with coordinates between the comet and Mars to see if we can get both of them in the same field of view. But again, I think it's a lost cause. But I'm up for an adventure. How about you folks?
Go for it.
All right, that's the spirit. But we'll do short exposures, so it shouldn't be too bad. Okay, so I think let me double check my entry there. Okay, that looks pretty good. And the declination is 22, which is positive. Well, we don't need to put that. 59. I don't know how precise I have to be here, but it helps. And 15.4. Okay, so we don't want to use hydrogen alpha. We're going to use the clear luminance filter. And let's do about, let's just try 180 minutes again. That's what I did last night. So let's give it a shot there. All right, so of course, here is our target, which is Comet C2022 E3 ZTF. But let's just call it Comet Zwicky because that is who it's named after. So of course, as you may have heard, I mentioned this last month when we looked at it as a bonus last time because we had to wait for it to rise, but that is not a problem tonight. This comet was discovered on March 2nd 2022 by astronomers Bryce Bolin and Frank Maska using the Zwicky Transit Facility, which is on Mount Palomar, as I recall. And so when the comet was discovered, it was magnitude 17.3, so very, very faint. So that's why many of these comets have funky names today, because these automated surveys like the ZTF survey, they find these things before amateurs do. Seeing a comet named after an amateur is very rare today. And when it was discovered, it was about 4.3 AU, or 640 million kilometers. That's probably around 400 million miles from the sun. It was at first classified as an asteroid, but of course later observations revealed it to be a comet, and it is a comet from what we call the Oort cloud, a kind of spherical collection of comets we know exist all around the solar system. Even though we've never directly viewed an object in the Oort cloud, we know the Oort cloud exists because comets like this that can pass near, like the Dippers, they got to come from somewhere way, way, way out there. Now, this comet has reached perihelion on January 12th, 2023. You can hear the my other computer here look for a guide star. That's the little chime in from Windows there you hear. It's tracking down a guide star, and it has found one, so we're going to guide there. But when this comet reached perihelion on January 12th, 2023, it was 166 million kilometers, or about 1.11 AU from the sun. Of course, 1 AU is 93 million miles. So 1.11 AU, that's probably around 100 million miles from the sun. So this one was not a sun grazer. It did not get super close to the sun. And it reached closest approach to Earth on February 1st at a distance of 0.2 AU, or 42 million kilometers, probably around 30 million miles or so. And it has reached naked eye visibility, but you got to have, you needed dark skies to see it. Right now, according to Starry Night, I marked down a magnitude of 6.74 here. So yeah, under exceptionally dark skies, you can probably still see this with the unaided eye, but from around here with all the light pollution, no way. But I did look at it in binoculars last night, and it was really, really easy. So the actual comet, the actual dirty snowball, that's only about 10 kilometers across, a little over 6 miles in diameter. And it's currently 0.472 AU from the sun. Multiply this by 93 million miles, and that'll give it to you in miles. And so here's a view for 9:45. So we're a little past this as we record this here. And so again, if we're lucky, the chip of the camera will be in this orientation, and we'll get Mars way up here and the comet way down there. But again, the odds of that are kind of remote. So there's a pretty good chance we'll get neither. We might just get a little gap here in Taurus, but we might get a little something. So here you can see Aldebaran and the Hyades and the Pleiades. So if you do have clear skies right after the session, you can run out and check it out. If you find a little fuzz ball to the lower left of Mars, that's it. That's the comet. All right, let's see how we're doing. Almost done. Oh, the wind looks a little better. The wind is now 5.2 miles per hour. Hey, that's pretty good. So you can see the tracking has improved. I'm not sure what the other scale here is for, but this is the kind of scene. So there we go. And this little funky thing here, this is an image of the guide star that it selected, but this does not update, unfortunately. So you can't see it like bob around. Yep, so we're doing a 3-minute exposure with the clear luminance filter. No colors or no gradients to let through to certain types of light. And we currently have about 69 people joining us, which is pretty amazing considering we delayed one day And, you know, it is Super Bowl Sunday. Some people actually do care about that. I'm glad I'm not one of them. All right, we're done. For some reason, it always looks like it goes past the time, but it doesn't really. I don't know why it does that. All right, so the image has to download. Needs a little processing and rescaled and nothing. There's Mars. So Mars isn't in the corner. Let's wait for it to load. Yep, I was afraid of that. Well, we took a shot, right? Let's see what we got here. So that's Mars up there. Still dazzling like it was last night. And let's scroll down. Did we get a little fuzz here anywhere? Nothing. Absolutely nothing. Oh, there's a neat little string of stars there. That's interesting. Look at that. So we did find something. All right, so let's try for just the comet itself. I was afraid that was going to happen. So I also have the coordinates for the comet itself handy currently. And so we're going to enter, not the azimuth and altitude. That would be bad. It's pretty similar in right ascension. But we'll try 43.34. And for declination, we got to change it to, this is the important one, to about 20 degrees. Change that 5 to a 2. We get to keep the 9. And it's changing on me. We'll say 1.5. I forgot what I just said. Of course, it keeps changing on me. Well, heck, let's just try 0, 0. That sucker's moving. All right, I think we're good. Let's go ahead and do another 3-minute shot. So let's go ahead and stop sharing for a minute. I can check the chat. Oh, the final is the Chiefs won the Super Bowl. Did anybody win any money? If so, I get 10%. What's the dew point? I don't know. It does. Oh, the dew point. Yeah, it's here. The dew point is 16.5. So we're not going to get any dew. Dew is never a problem out there.
Did you say 16.16?
For the dew point?
Yeah.
16.5. 16.5 degrees Fahrenheit. That is the current dew point out west.
That's
In fact,
crazy.
let's go back to the browser again. I'm going to switch over to the all sky. And it looks like we're getting red lighting now. It's still too bright though. Got to really get on him about that. So the kind of brownish tinge has died down a bit. It'll get a nice shade of blackish later. But you know, it's soaking up sunlight all day. So you can also scroll down and see the wind. This is the wind speed here. So normally this red dotted line is at 10 miles per hour. But I don't want the telescope to park itself. All right, we're going to mute everybody there. Again, you can unmute yourself, but remember, folks, we're on Zoom. Everything you do, we can hear. So it looks like the wind, you know, it's still down to about roughly 5, but now it's about 3.7 miles per hour, which is good because we don't want it terribly high for the 20-inch. And of course, you can see the darkness. It's nice and flat because it's nice and dark now. And the humidity is just disgustingly low. And you can see the ambient temperature and the dew point. So it's all here. And again, you can check this out pretty much every day except from July to the end of September. And again, it reloads every 4 minutes or so, but the new image and the reload never are coordinated. There's no way to really get it to do that for everybody. All right, folks. Shall we go back? I guess we should have stuck with the browser because we don't have to wait too long. Oh, no, we're getting there. It does take a little time to find a guide star. So it's not 3 minutes and we're done. It takes, got to wait a minute to get the guide star or so. Then they got to do the exposure. It looks like we're getting like Mars shining down on us. Can't see that here though, just in the really tiny thumbnail. Do you guys want this picture too? Should I include this picture with the download of Mars and just a bunch of stars?
Yes.
Okay, I will include this one too. It's probably too late, but toward the end of the exposure, it does plate solving. It, compares it with other pictures of the sky and tells you how many stars are in the field of view, but that's probably come and gone already. Oh no, that can't be right. Well, this is probably for the current exposure. It has to be, it's way more than 612, but those are the catalog stars. And there's like probably a few thousand in there. Now the wind is 4.2 miles per hour, but still a little choppy. So the scene was forecast to be pretty rough anyway. So that's pretty good. So how many folks are joining us for the first time? You can tell me verbally, or you can mention in the chat. I'd be curious to know how many first timers we got. $10 seconds. Oh boy. 5 seconds. We need a countdown clock. All right. Now we should definitely have some comet here. If not, I will eat a bug. If I can find one. We need Jeopardy music. I keep forgetting to download some Jeopardy music while we wait. There we go. I see a little fuzzball there right in the center. Boy, those coordinates were pretty good. All righty. Are we ready for some comet?
Yeah, let's see it.
Here we go. There's a little booger.
Ooh.
Oh, it got
Nice.
That's amazing.
Yeah.
Look at that rude satellite that crossed through.
Yeah, what in the world?
Yeah, ignore
Awesome.
it. Just ignore it. It's a great shot.
Well, I was gonna say, at least it's not a balloon, right?
What a bum.
Those things are everywhere. The freaking balloons everywhere. All right, so of course, this bright point there is the nucleus. So the actual comet is buried deep inside the nucleus there with the coma. We got the nucleus, we got the coma. This broad part is the dust tail, basically dust from the comet that may contribute to the zodiacal light. Who knows? And this, you can just barely see it. This is the ion tail. And it's basically ionized atoms and free electrons. So the sun is exactly this way, because the ion tail is the one that points directly away from the sun. The dust tail is made of heavier particles, like silicate material, like, stuff the size of a grain of sand. So that tends to trail the comet a bit. So the comet is moving kind of this way to the lower left. And yep, there's no sign of Mars. Oh, there's a nice cluster here. Oh, that's interesting. Let me see. I have oh, that is NGC 1647 right there. Let's see if I can get a few basic bits of info on that for you. Let's see, it's about 1,800 light years away. So that's cool. We captured the comet near an open cluster. That's compensation for not having Mars in the field of view anymore. All right.
Richard,
Yeah.
quick question for you on the direction of the tail, the ion tail and the dust tail. Why is the dust tail not pointed away from the sun? Is there some other forces on that?
Well, it is generally, but again, the dust tail is made of heavier particles that you know that get ejected and just tend to begin to trail behind the comet.
So that's more the direction of the comet motion is
Yeah.
more involved in that than as opposed to the ion.
Exactly. Yep.
Thanks.
Yep. They're all kind of maybe losing momentum too as they kind of maybe bash into one another, but it's not quite that dense. All right. Well, we better get going here. We got one more target. Let me scroll down here and type it in while I'm here. So now we're going to do NGC, although as we'll see, this thing has many designations, but we'll do NGC 2244. Make sure we hit that. And again, I don't usually, we'll do one more of these, but let's go ahead and do a 10-minute shot, although we're running a little long there, but we had to do 2 comet pictures. But, you know, we live dangerously here. So let me tell you about this target here. And again, we're going to give, I can hear somebody typing there. So we're going to give everybody a mute again. And I'm sharing that screen already. I wish it would change for me, but it doesn't. All right, so here's our target. I'm just going to call it NGC 2244, but again, that's technically not correct, but it's good enough for government work. And we're going to look at the Rosette Nebula, probably my favorite emission nebula in the sky. So the nebula is also cataloged as Caldwell 49. The Caldwell list is what was created by Sir Patrick Moore, a very famous English astronomer who you know did a lot of outreach in his day. And so his name is technically Moore Caldwell. So he called it the Caldwell catalog because he couldn't use the capital M, because that was taken for the Messier catalog. And so the open cluster, which is actually NGC 2244, is cataloged separately as Caldwell 50. So we get 2 Caldwell objects here for the price of 1. Hey, that's pretty good. And so this target is in the constellation Monoceros, which, as our member Anna knows, is a very difficult constellation to find because you got to have dark skies to see it. So of Monoceros's 60 stars, because it's a big constellation, none shine brighter than magnitude 3.9. And the nebula itself has several new general catalog or NGC designations. There's NGC 2237, which is another open cluster. There's NGC 2238, another cluster. There's NGC 2246, which is parts of the nebulous region. And again, NGC 2244 is actually the bright cluster and the center of the Rosette Nebula. So this target was discovered piece by piece by the English astronomer John Herschel, who is the son of William Herschel, who found NGC 2244. The German astronomer Albert Marth discovered NGC 2238, and the American astronomer Lewis Swift was the first to observe NGC 2237 and NGC 2246. I hope you're writing all that down because there's going to be a quiz later. So the Rosette Nebula is again big. Let's back up here. So you can see it shows the measurement here as 24 arc minutes, but that's probably for just the cluster. I should change that to reflect the nebula. So this whole region is huge. It covers 4 times as much sky as the moon. And it's also a very big emission nebula. It's about 3 times as far, but 3 times the size of the Orion Nebula. If this thing were the same distance as the Orion Nebula, it would fill a good chunk of the constellation Orion. And it's located halfway between Procyon and Betelgeuse. So we'll back up here and do that because you can see here's Procyon. here's Betelgeuse. So, you know, there's no really bright stars in Monticeros to guide your way. So you just kind of draw a line between the two and go maybe a little bit closer to Betelgeuse, and you'll run right into it. If you do binocular viewing or a telescope with no go-to, of course, everyone today has go-to. So again, here we can find it here. You can try to star hop from Procyon as well. But again, I think the other trick between Procyon and Betelgeuse works better. But because if you go from Procyon, you'll probably get a little astray. And so here's a close-up. And by the way, these atlas views are from Scion Telescope's Pocket Sky Atlas that I sort of, you know, liberated through scanning and cleaned up a bit. So these are scans of the star atlas. So if you're looking for a good star atlas, I highly recommend Scion Telescope's Jumbo Pocket Sky Atlas. So you can see the Rosette Nebula has several NGC designations because it's pretty big. All right, let's keep moving here. Let's go back, see how we're doing. I heard the other computer look for a guide star, which it was successful, and we are currently into our exposure. And again, we're doing 10 minutes in hydrogen alpha. So we got some time to kill, which means we got more time for comments and questions. And I'd love to hear them, either one. No criticism, just keep those to yourself.
Richard,
Yes.
I would like to ask you if later on in the week or something like that, I'm trying to find the comet. Where would you find out there in terms of information the coordinates at any moment in time for that comet?
On my iPad here, I use the coordinates I used tonight came from my iPad using an app called Sky Safari.
Sky Safari. Okay.
Yep. On my laptop here, which is like right, you know, here, I use Starry Night.
Okay.
If you don't want to buy any of those, you can download Stellarium for free, but you have to do a few extra. You have to go through a little more work to get the current comet coordinates, because I don't believe it comes standard with the free download. But it's not hard to do.
Well,
I mean,
No, Stellarium has the comet on there.
yeah, I use, that's what I was using to find it. So it does work. I don't think I've got anything extra on this. So it does work. And that's which is good.
all right. Thank you.
And yeah, from the question in the chat there, I am still using the Takahashi. This is our last target for the Takahashi. And then we'll move on to the big scope. Oh, and I see Mike Patton is going to join us. Mike Patton is the gentleman that owns the observatory our telescope is in. Yep. So I'm not 100% familiar with Stellarium because I always use against Starry Night or Sky Safari. To actually control the telescope, we use a program called the SkyX because we have to, because the mount was built by a company called Software Bisque, and guess who designed the SkyX? Yeah, Software Bisque. So they make you use that program to control the mount. You have to.
Richard, I download this Earth Sky News. This gives you the information free.
Oh, there you go.
Earth Sky News.
All right. Yeah, Earth Sky News. Yep, I'm familiar with that. And that gives you weekly coordinates for the comet?
Yes.
Okay.
They're giving it daily for the last 1 week.
All right, that's handy.
Yeah, I found if you're using an app to get the coordinates, you need to make sure it's an app that's updating regularly, because that guy is really moving and you can't take your time putting them in. You have to put them in and hit go.
Yep. And you can see Sky Safari put it right in the center for us. That looked really good to me.
Richard, Jane from Fort Wayne, Indiana
Oh, welcome.
Hi, I'm just wondering what you think the best place fairly close to Indiana, Michigan is to see the stars.
Not too far from either of us. There's the TK Lawless Park. That's a dark sky park. It sounds like it's difficult to maybe get in there with the telescope at night. But you know, if you just want to walk in, look at the comet with binoculars or a telescope you can carry, because I don't know if you can really get in at night. That sounds like that's a problem. Yeah, there's the TK Lawless Park, but there's also the Lake Hudson Dark Sky Preserve. That's over on the southeast part of the state. I've never been there at night, but I've been there during the day. And if you make a wrong turn, go into Lake Hudson, you end up in Ohio really quick because it's really close to the border. So I've done that. But like, oh, I forgot to turn there. So now I'm in Ohio.
So you said Lake Hudson.
Lake Hudson,
Sky,
yep.
Sky Park?
I think it's Sky Park, but Lake Hudson Dark Sky Preserve or something like that. It's not a International Dark Sky Association Dark Sky Preserve.
It's a state park.
It's a state park, yeah. Jeff would know. He practically lives there. He's like right in his backyard.
Lake Hudson is a Michigan state park. It'll probably require a $17 park pass or whatever for a daily. But the lowbrows go out there frequently. It's almost directly south of Adrian, if I'm not mistaken. But
Thank you.
They get typical Bortle 3 and 4 skies out there, so it's pretty decent.
Yeah.
Thanks.
All right. Let's check in with the browser, see how we're doing. Check in with ATP, which is on the browser. There we go. There, we're trucking along. Oh, big old spike there in the guiding, but nope. Guide star looks good. There, take a look at the comet again. Isn't it a cute little booger? Just a cute little ice ball.
Look at all those satellites.
Yeah, at least one. We did get the bonus open cluster. That was very nice. Well, there's another satellite. Or no, I think that might be artifact of the chip. So how many folks have seen the comet visually for yourself? You know, possibly naked eye, but binoculars or telescope? Sure, I'll stop share for a minute. You know, some people can raise their hand and tell me if they've seen the comet, or you can just tell me or put it in the chat. Oh, great. So looks like some of you have. I know Mike Patton, he's seen it with the naked eye because he's under those dark skies, and we hate him for it.
Saw it at George Observatory last night in Houston.
Oh, great.
I think from where I am, it would be impossible to see it with the naked eye, but definitely binoculars and a telescope.
Yeah, there's no way to do it with the naked eye around here.
Binoculars and a telescope in Indianapolis too, but pretty decent.
As Mike Mitchell, Oklahoma City, I've been tracking it since September. I haven't seen it naked eye, but I've seen it binoculars many times with a telescope.
Great. Yep. It's no Neowise, and Neowise was no Hale-Bopp. Some people even preferred Hyakutake to Hale-Bopp because the tail was much longer. And I didn't get to see Comet McNaught because the Earth is curved. But that put on one hell of a show in the Southern Hemisphere in 2007. And then there was a Comet Lovejoy. There have been several of them, but Comet Lovejoy put on a good show in the Southern Hemisphere in 2011 as well. So the Southern Hemisphere folks seem to get the really good ones. All right, let's go back. Oh, good timing there. All right, so we just finished up. It's going to go through its whole shtick here. There it is. Oh, that looks good. Again, we have to wait for the little bonks. There's one bonk. There's two. And the little window will pop up. There we go. All right, folks, are we ready? I want to hear some. Now, I want to hear some genuine oohs and ahs, not like fake ones. Come on. All right, here we go.
Ooh, yeah. Ooh, wow.
Wow.
Awesome.
Wow.
Look at this.
Wow, that's cool.
It's upside down.
Very nice.
There's no such thing. All right, so the Rosette Nebula, you can clearly see why it's called the Rosette Nebula, but I've read sometimes it's referred to as the Skull Nebula because some people can see a skull.
Oh, yeah.
Now, I guess maybe you can. Maybe there's like an eye socket here, an eye socket there. Maybe that's what they're talking about. But, you know, this is what draws my attention, so okay. But there is another object called the Skull Nebula. That's NGC 246. So we can't call it that. But, you know, the Rosette Nebula is a much more famous name. And of course, the nebula, as mentioned, surrounds the cluster NGC 2244, which is this cluster right here, smack dab in the center. And so the cluster contains about 100 members, and it formed within the past 5 million years. So like the Heart Nebula, this is another stellar nursery, and these are absolute babies, at least on the stellar scale. For stars, they are very young. The cluster itself is about 43 light years in diameter, while the nebula is 130 light years across. The mass of the nebula is about 100 or 10,000 solar masses, making it one of the more massive emission nebulae known. So again, it's a big one. It's really, really big. And here's a really fun fact. On April 16th, 2019, the Oklahoma legislature passed HB 1292, making the Rosette Nebula the official state astronomical object. Oklahoma Governor Kevin Stitt signed it into law on April 22nd, 2019. So Oklahoma has a state designated deep sky object. How come Michigan doesn't have one of those? I guess for Michigan, it would be like a cloud.
I was gonna say, what's our deep sky object? Maybe it is the cloud.
Yeah, I know, but we need an actual deep sky object. If you had to choose one for Michigan, which one would you choose? Gosh, I don't know. Maybe the Dumbbell Nebula?
This is Mike again. Our club was there when he signed that. We got a picture of him signing the proclamation out at our observatory at Cheddar Ranch Observatory.
Oh, cool. That's very cool. And remember, when you get to download these images later, you get to download the full resolution version so you can zoom in here and see even more detail than we can do here, because it would take too long to download the picture and open the program and process, you know, do a quick processing job and show it to you. So we can't do that here. We just use the big thumbnail image here. But there you go, the Rosette Nebula. Pick your NGC number, because again, there are quite a few. All right, so now we're going to scroll down here, and it is time to switch telescopes, and we have a special script just for that. So we're going to let that run its course. It's going to do its whole spiel there, its whole program set. And let me introduce you to our other telescope. So the big scope is a plane wave CDK, or corrected Dull Kirkham 20 telescope, which means it has a 20-inch primary mirror, which is ellipsoidal, and it has a kind of spherical secondary with a lens group in the back to help give us, you know, coma-free no stigmatism, and a relatively flat field, but we do have some vignetting because we had to relocate the secondary mirror. Oh, we're going to mute everybody again. That wasn't needed. And so you can see again, we have a current picture of the telescope taken just this past week. You can see our Takahashi with the moonlight. That's a clear giveaway that it's a new picture. And I want to thank Mike Patton for taking baby wipes to the telescope and making it all clean for the pictures, because it was mighty dusty. And as you can read here, I won't go through the whole thing. The main scope has an all carbon fiber construction to help minimize thermal expansion. And you can see the imaging train here on the back. We can zoom in there. We use the same exact camera on the plane wave as we do the Takahashi, which has caused some problems through the years when you have the same camera with the same driver, and sometimes there've been mix-ups. But we got the same camera, same filter and filter wheels. But we have this gadget here called an on-axis guider. I can explain all that if we have time later, but it takes forever to go through. And that feeds in light to the auto guider, which is what has been guiding the images for us all night. Oh, and we have successfully switched telescopes. That's what the bonk was. And of course, both the plane wave and Takahashi are supported by our massive equatorial mount, a software BISC Paramount ME2, which is why we had to delay the start of the season this year, because first we had to delay November because of roof issues, which was not related to the telescope. But then in December, we had a board, the computer board kind of burnt out on us, but we had Optech fix it for us. So we really appreciate them. If Optech wasn't able to fix the board, we would have had to cancel the entire season, because they are still on back order. All right, so let me switch here before I introduce you to our target. Let me go back to ACP real quick. And while we're talking, I'm going to enter our first target for the plane wave. It's an NGC, and we're going to do 1977.
Did you change the focal length?
I'm so glad you mentioned that, Anna. You get the gold star for today, because I did not. So that would have caused some problems. Not serious problems, but still. So ACP can only use one telescope at a time. So I have to keep changing the aperture and focal length so it finds things for me correctly. Okay, so now it'll put it directly in the center. And we're going to do now this is a nebula, but mostly a reflection nebula. So H alpha isn't the best choice, but luminance really brings this sucker out. So let's go ahead and hit acquire image like that. So here's our target, NGC 1977, the Running Man Nebula. And it's also cataloged as Sharpless 279, which is an emission nebula that includes a reflection nebula known as the Running Man Nebula. It is the northernmost part of Orion's sword, lying about 0.6 degrees north of the nebula. So it looks like we're pointed right at the Orion Nebula in this view, but we're actually looking just a little bit north of the Orion Nebula as shown here. So this is the Orion Nebula, this kind of oblong blob here. And just above it is NGC 1977. It's not even labeled on the Pocket Sky Atlas because it's pretty crowded around here. So NGC 1977 was discovered by, guess, William Herschel. Anytime I say guess, it's William Herschel. In 1786, using a 18.7-inch f13 speculum reflector. Because back in his day, the mirrors were made of an alloy of tin and copper called speculum. They didn't have glass like Pyrex with aluminum or silver coatings. They basically had this kind of reflective metal that only had half the reflectivity of modern day reflecting telescopes. And of course, the nebula is pretty easy to see in small telescopes, but the Running Man, which is a dark area, is difficult to pick out visually. Some people can't see it. To me, as you'll see later, it looks like Gumby. I'll kind of try to point that out to you. All right, so let's go back to the browser, see how we're doing. I don't know if we have a guide star yet, but it's still working on it. Oh, of course, the telescope had the slew, and we always miss that. Let's of course, the image looks like the Heart Nebula, where it was for the Heart Nebula. So let's reload there. And we missed the telescope slewing. And there we go. There's the current view of the telescope. You can see the Takahashi's closed up now because we are using the big scope. And yeah, when I do serious imaging, I do turn off the webcam because I don't want the infrared light going into the telescope here. But I'm going to keep it open tonight. But it doesn't really ever seem to cause any issues that I've noticed. But I've never done a hard study to investigate that. But as a precaution, I tend to turn off the webcam. And you can hear the window chime because we're looking for that guide star. And we found one. Hooray! And yes, even when we use the Takahashi, all of our guiding is done with the big scope. So when we use the Tak, the 20-inch becomes the largest guide scope probably in the world. Don't quote me directly on that, but it's a pretty big guide scope, you got to admit. All right, so how are we doing? All right, we're doing good there. And yeah, wasn't that a sweet picture of the Rosette Nebula? Oh boy. You can see some nebulosity trail off to the lower right here. If we did an even longer picture, we could probably pick that up, but we're not going to do any 20-minute exposures for goodness sake. It's only a 2-hour show. All right, so we don't have 10 minutes to wait this time, just about 5. So let's stop sharing screens here. And again, I welcome any questions about the equipment, the observatory, the targets, the club, anything. Or if anyone has any astronomy reports to share, we welcome anything while we're waiting. You guys are a quiet crowd tonight. You're exhausted from the Super Bowl, right? You had
Right.
Super Bowl fever and now you're all burnt out.
It was an exhausting game.
Well, this is Mike from Oklahoma City again. We had a comet observing event on the 3rd, Friday the 3rd, and got a little bit of advertising on the local news channel and all. I wasn't sure how many people would come out, but we had between 400 and 500 people come out.
Wow.
Yeah, we're absolutely amazed. And,
that's great.
We had about 20 club members there. Plus, we had at least a half dozen folks with telescopes come out and set up with us that weren't club members. So
wow.
Everybody who came out got to see the comet, and it was an overwhelming success. And we had our meeting the following Friday, our Oklahoma City Astronomy Club meeting, and we got at least 8 new members out of it too. So that was great too.
Great.
So anyway, the outreach event, the comet, a lot of interest in the comet, and so still visible. I might try something like that in your area, and you might be surprised at the outcome. Michigan's
a little harder because, again, right now is the exception rather than the rule where we have clear skies, like a few nights of clear skies. You know, there's no way we could have predicted that well enough in advance to do any publicity to bring people out, but I wish we could have. You just can't do stuff like that in Michigan. Ours was partly cloudy predicted all the way up to that morning, and then they changed the forecast to clear, and it worked out perfectly. Although I was flabbergasted that many people came out. It was literally 32 degrees, so it was freezing, and we still had that many people come out. Yeah, that's great.
Mike, where'd you say you were from? Where you had the conference?
I'm from Oklahoma City. I'm also a member of the Oklahoma City Astronomy Club. I'm actually the observing and outreach co-coordinator for the club here.
Okay, oh, that's great.
So,
Well, thanks for joining us and sharing that. That was great.
Well, you got Kalamazoo does a lot of online stuff, so I went ahead and joined your club too. So
super. I was pretty sure you did, but we have so many people, I can't keep track of everyone anymore. It's too hard. Back in the old days when we actually folded and mailed newsletters, that helped me remember everyone's name. But of course, we don't do that anymore. Thank goodness.
Well, I'd be remiss if I didn't make a plug. On September 22nd and 23rd is an event held in southeastern Michigan. Of course, it's the Astronomy at the Beach event that we hold, and it's basically open to anybody who wants to bring their telescope out to the field. And it's held 6 to midnight on those 2 nights. And we basically got about 9 clubs in the southeastern Michigan area that helped put it on. And I think last year was kind of a down year, and we still got about 5,000 people to come out. A good year will get close to 8,000 to 10,000. So it's a big public outreach event. And if you're not doing anything that weekend, mark it down. We usually schedule it so that the moon isn't too intrusive, but people still like to see the moons out on there. But it's a good time to make a plug for it.
Great.
Where is that again?
It's held at Island Lake State Park. It's near Brighton, Michigan. And like any state park in Michigan, you got to have your recreational pass. But aside from that, it's a free event. Yep. And we try to make it as kid friendly as we can so that everybody gets a chance to get out there. In the past, we've had up to 70, 80 telescopes out in our telescope field. So pretty extensive.
Oh,
thank you.
I do believe I heard a chime there. So let's head back to the browser. Oh, there we go. Now, when I first took a picture of this with a 20-inch, I gasped because I didn't realize how cool it was going to be. Are we ready? Here we go. The Running Man Nebula.
Ooh.
Nice.
Ah.
Wow.
We got to scroll to see the whole thing here.
Big.
Yeah.
I always wondered where he was running to.
Who says you have to run anywhere? Sometimes you just want to run.
Maybe running from.
So to me, it looks like Gumby. This is his head. He has like a leg here and a leg here. So to me, it looks like Gumby. So like the Orion Nebula, the Running Man is associated with Orion's giant molecular cloud, which fills much of the constellation. Pretty much the entire constellation of Orion is filled with nebulosity. You just can't see it all. And the nebula is likely excited by 42 Orionis, which is a B1V, a B-type main sequence star in NGC 1977. It could be one of the really bright ones here, who I'm not really sure which one. And it appears as a 4.6 magnitude star, about 3.8 arc minutes from the center of Sharpless 2-279, which is the Running Man Nebula, and part of a much larger nebula that is known as the Orion Cloud Molecular Complex. And so the complex extends throughout the constellation of Orion, and it includes Barnard's Loop, which is even too big to share with the Takahashi, the Horsehead Nebula, which we looked at last month with the Takahashi, M42, M43, which we looked at last month, and also M78, and the Flame Nebula, which is near the Horsehead, and we did see the Flame Nebula last month as well, because we got several targets for the price of one with the talk in that region last month. So you can see a big old cloud there in front of the Running Man, so you get a sense of 3D here. But it's just a stunning target. And the really bright stars and even the spikes, which are caused by the telescope's spider vane that holds the secondary mirror, even they help really enhance the scene. So it's just a beautiful region of the sky. All righty, so let's go on to our next target. This is one we've done before as a bonus object but we've never done it formally. So we're going to do M41. And let's go ahead and do 5 minutes again with the clear luminance filter, and go ahead and hit acquire image. I think I hit it. Yep. The little siren is going, which you can't see. So I think it's working. Yeah, well, it started. Sometimes you're just never sure. So here we go. We're going to do M41, which is referred to as the little beehive cluster because it's a bit smaller version of the beehive cluster in the constellation Cancer, the crab. And so it's sometimes referred to as the dog's tag because it's in the constellation Canis Major, the great dog. And it is Canis Major's only Messier object, which is amazing because Canis Major is a pretty good sized constellation. So here's its general location in the sky. We can see Sirius, and here's the dog here. It doesn't show the triangular head in this view, but maybe we'll add that in the future. So at magnitude 4.5, it is easily visible to the unaided eye under clear, dark skies, although last night I needed binoculars to see it through the light pollution of downtown Kalamazoo. And so if you can't see it naked eye, that's because, like many of us, we live near big cities. And this was possibly, and I stress possibly, viewed by Aristotle in 325 BCE as one of the mysterious cloudy spots in the sky. And if true, that would make M41 the faintest object reported in classical antiquity. So you could think of it maybe as the first deep sky object. But there's a good chance that Aristotle was referring to a cloudy patch in the Milky Way and not the cluster itself. But it was definitely discovered by the Italian astronomer Giovanni Battista Hodierna in 1654. He was the first to observe it and catalog it. And it was rediscovered by John Flamsteed in England in 1702, and again by Le Gentil in 1749. If you don't know Le Gentil, you might remember that name from back in like 2004 or 2012 with the Venus transit, because this guy went to like I think somewhere in Madagascar, India or something like that to observe the Venus transit and got stranded for many, many years before he finally returned home to France, but was declared dead and had to retrieve many of his belongings. So he had quite the story to observe the transit of Venus. And it was observed by Charles Messier on January 16th, 1765, and added to his catalog of comet masqueraders. Because, of course, the Messier catalog was intended to be an object of list of objects that look like comets, but turn out to be some of the best deep sky objects in the sky. And again, it's right near Sirius. It's a very easy star hop for beginners. Just go to Sirius and basically head due south. And it's about 4 degrees, almost exactly south of Sirius. So it is really easy to find with binoculars. And along with Sirius, it forms a roughly equilateral triangle with Nu Canis Majoris to the west, which is right here, Nu 2, not the other two, but Nu 2, which is the brightest of them all. So you can see it forms a little triangle there. And you can see that in binoculars. And with an angular diameter larger than the moon, it can be partially resolved in the stars in binoculars. So again, it's a great target in binoculars, or even a short focal length wide field refractor, or even a reflector. So there you go. There's a little intro of M41. We like to do a little more here than just, show you this screen the whole time as we take pictures, give you a little background info to give it a little more meaning. So we found our guide star again. We're getting good luck with guide star searches tonight, and we're guiding away. So let's, while we're here, let's hop back over to the all sky camera, and you can see it's not quite as brownish as it was from the sun. So it's getting a little more black as it normally looks. And we've even lost Jupiter now. So we've lost both Venus and Jupiter, and maybe just a hint, an absolute hint of zodiacal light, but it's pretty much gone now. And we still got those clouds hanging low on the southeast, but they're just sitting there. They're not moving in, thank goodness. So we should be free of clouds for the duration of the session, because it's supposed to get cloudier later. So no extra imaging for me tonight. And yeah, as promised, here's the bowl of the Big Dipper. And our last target for the night is right about here. So that kind of spoils it for some of you, because you probably know what I'm going to look at. Well, you have a choice of two objects right near each other. But yeah, we're going to look right around here next. So that's why I saved it for last. Give it time to get high enough to see. And we should check in with the telescope too. I don't go to the telescope enough. I know that, but let's try to remedy that. We'll have to hit probably reload again, because we have only DSL out there. So the internet's a little slow, but it may mainly be a browser issue. The browser just stops streaming it when you go to another screen. And there we go. So now the telescope is on the west end. And we got this object just in time for it crosses the meridian. Because sometimes when an object first crosses the meridian, the telescope will, slew to the other side of the sky, and it does something called a wait flip. It waits for it to go past the meridian a little bit. And sometimes that can be a long wait. Fortunately, that hasn't happened during a viewing session yet, thank goodness, because that would really slow things down. And you can see this funny white square here. This is our flat field box for the plane wave. So what we do is this box here, this kind of flat screen, gets really bright, like bright white, and we basically take flat fields. We take basically, kind of bland pictures that bring out dust spots on the chip or the optics, and also vignetting where the edges look a little darker than the rest of the photo, and we subtract that from the actual images we take, which we call subframes.
When you do that, do you like go out of focus or something like that just to help the process, or what?
It makes no difference where the focus is to take flat fields, So that's the good part.
Because it's that flat.
There's nothing to focus on either. Yeah.
It's probably too darn close to focus on anyways. Okay.
Yeah. Yep. And each of these counterweights is about 30 pounds, by the way. We have 150 pound there on the end, which we need to remedy because the heavyweight should be toward the center. So we got to fix that one of these days. But, it's a bit scary to take all the counterweights off and put the big one on first. So we have to have several people out there someday to fix that. But we'll get to it. But it doesn't cause any issues that we've noticed.
And so why would you want the heavy weight towards the center? Is that just keep it from bouncing or wobbling?
There's less stress on the mount too. It's mainly a mount stress
so
issue.
That we don't bend the bar or...
Yeah, that's not really an issue. It's just more for the motors that track that move the mount. All right, we just finished up there, so let's take a look at M41. We should get some nice sparkly stars. There we go. Ooh, very pretty. It's been a while since we've done this one. So I'm exactly sure it's going to look like. There we go. All right, are we ready?
Ready.
Here we go. Kaboom.
Cool.
Wow.
Sparkly.
That's a lot of stars.
Wow.
Very nice. Very nice.
And we got we got to scroll here because our new thumbnail is much bigger than it used to be. Of course, the first thing any good astrophotographer does is start looking for galaxies, but I don't think there's any here. We're looking right into the Milky Way, so that's not too surprising.
So you say this is a thumbnail. There's probably a bigger file hidden someplace that you could download also?
Yeah, yep. What happens as soon as the image, the main image is done, it uploads to our cloud account, which is Google Drive. And then I'll download those, and I'll do a little processing on them because you have to, because all the raw images are in FITS format. And when you first open a FITS file, it's like dark. So you have to stretch it out. But of course, the program we use to take the image, MaximDL, that does a little stretching for us to create this kind of thumbnail view. All right, so you can go ahead and count them here. The cluster contains about 100 stars, but we're seeing some, many more background stars as well. And the brightest, which I'm guessing is either this one or this one, probably this one, is near the cluster center. That's got to be it. And it's about magnitude 6.9, which is right at the theoretical edge of really good naked eye dark sky visibility. It's a yellow-orange K3 giant, about 700 times the luminosity of the sun. And what that means, luminosity, is two factors determine luminosity. There's surface area and temperature. But surface area is really more important because the larger the surface area of the star, the more area it has to emit light. So even though the star is pretty cool, a K3 giant has a cooler surface than the sun, it's much brighter because it's huge. It's a much, much bigger star. But the hottest star is spectral type A0, and don't ask me which one that is. So it does have a type A star, which are much hotter stars. And some star chains, if you look, you can see several star chains, form a backward question mark. And I was going to see if I could spot that. Maybe here? If I had to guess, this is the backward question mark that people see? What do you think? Or it could go the other way. No, it's probably the other way, right? No, but that's not backwards. Oh, wait, I forgot. The on-axis guider flips the image. So this would be truly backwards. And when I download these and process them, I try to remember to flip it horizontally so it looks the way you would see it in the sky. So this, all images with the plane wave, because of that on-axis guider, are mirror images. So left and right are reversed in this picture. So this would be the backward question mark, which looks correct here. And of course, you can probably make out lots of parallelograms because there are so many stars. And so the true diameter of the cluster is about 25 light years, and it has a total luminosity of 8,000 suns. Its estimated age is between 190 and 280 million years. And cluster properties and dynamics suggest a total life expectancy of about 500 million years for the cluster before it disintegrates. So, not all the stars will die, but what happens with open clusters is they encounter alien stars or other objects, and they gradually decay over time. So like the sun, for example, was once part of an open cluster. And this cluster also contains a handful of white dwarfs, and one has a mass of about 1.02 and 1.16 solar masses, which is one of the most massive known in an open cluster, because white dwarfs cannot be more massive than 1.4 solar masses. That's called the Chandrasekhar limit, because if you exceed that limit, the star blows up as a type 1a supernova. So that's bad. You don't want to be near one of those. And this cluster also has an unusually high number of binary stars. Between 40 to 80% of the stars in this cluster are variable or binary, but some are variable, which means they're probably eclipsing binaries as well. So there we go. Little more background to make it a little more meaningful and give you time to look at the target. M41. All right, so let's enter in our last official target for tonight, but we might have time for a few bonus targets. We'll do M81. Some of you probably guessed that from earlier, and we're going to hit acquire image. And it's going to do everything else automatically for us. Yep. So there we go, M81. which is called Bode's galaxy. So there are two galaxies right near each other. There's M81, and right nearby, as we'll see, there's another one called M82. And both these galaxies were discovered by the German astronomer Johann Elert Bode on December 31st, New Year's Eve, 1774. And Pierre Méchain, who was Charles Messier's assistant, found both galaxies independently in August 1779. You know, they didn't follow each other on Facebook or something, you know, right? And they reported the discovery to Charles Messier, or he reported the discovery to Charles Messier, who added them to the Messier catalog as M81 and M82 on February 9th, 1781. And of course, as with any galaxy, they have many designations. There's, of course, M81 for our current target, which is also known as NGC 3031 or UGC 5318. UGC is the Uppsala General Catalog, which contains about 12,921 galaxies from the Northern Hemisphere. And it's also known as PGC 28630. Which is the principal galaxy catalog, which contains 73,197 galaxies. So there's lots of galaxy catalogs out there because there are lots of galaxies to catalog. Now, it's often said that the Andromeda galaxy is the most distant object you can see with the unaided eye, but it is possible to see M81 with the unaided eye on clear spring nights when it's high, especially at high altitude, because some people can see beyond 7th magnitude. And you can see this is 6.94 magnitude. Uh-oh. Oh, that time we did not get a guide star. Maybe it's still maybe it's a little too low still. But you can see this target is 11.8 million light years away. So this could be perhaps the most distant object you can see with the naked eye. I can't, off the top of my head, I can't think of any other galaxy more distant that you might be able to make out. Someone might know one, but I don't. So here's where we're looking, right near the ear of Ursa Major, or, you know, kind of above the Big Dipper here. But that's where M81, M82 are. And so to find these, you can move 8 degrees west of Lambda Draconis, which I have up here. So 8 degrees west of Lambda in the constellation Draco, or 10 degrees northwest of Dubhe, which is Alpha Ursa Majoris here, but that's a long star hop. So it is kind of out here in the middle of nowhere, which makes it a little challenging to find for beginners. Or if you can use 23 Ursa Majoris, which is probably here somewhere, but I can't find it real quick. But it's 6.5 degrees northeast of 23 Ursa Majoris. So that's where it is in the sky. Maybe I cut off 23 Ursa Majoris. I'm not sure. I probably did. All right, so let's see how we're doing. And this time we did not get a guide star, so maybe it's a little too low. But there were stars in the camera.
Going to the Bode's galaxy.
But yeah, there's one guide star that could have locked on there, but it chose not to this time. But it is low. But 5 minutes with our Paramount shouldn't be too bad. It tracks really, really well. But the stars might be a little trailed, but I should be able to fix that in a little post-processing later.
The Bode's galaxy.
And we can check on the all-sky camera. Maybe we could be getting some thin clouds here, but it's hard to tell on the all-sky camera. And we'll have to update the image here again, or the view, but let's see what position the scope is in. We're looking kind of toward the northeast, so it should be kind of pointing above the roof. And there we go.
Yeah.
You can see the infrared light from our web cam is reflecting off this reflector we use when we park the telescope. This reflector helps sensors that we have over here on the wall tell us the scope is in a safe position to roll the roof back on, so we don't shear the top of the telescope off, because that would be bad. All right, so I think we'll just go ahead and stop sharing there. So again, our last target for tonight. This is a good one. I love this galaxy. Uh-oh, what was that? Well, that's interesting. Let's go back to the browser and see what happened. It's never stopped like that on us before. Okay. Come on, Zoom controls, go away. There we go. All right. I can never switch tabs because the Zoom controls get in the way. Come on. All right, fine. We'll just minimize the browser here. Shrink it a bit. Oh. Let's see. It's still going. I don't know what the script error was about. That's unusual. I'm not seeing these. I'm not seeing the message for the script error on the screen here. The image is still going. Well, I'm
no,
gonna let
it's stop recording.
Yeah, it looks like it's stuck at 216.
it is on the browser, but it's not on the remote computer. It's still going on the other computer. So let me, oh, that doesn't look good. Well, that looks terrible. In fact, this is unusual. This has never ever happened before. And trust me, folks, I've used this telescope a lot. Huh. That is very unusual. Okay. Yeah, that's software for you.
So I don't feel bad. He's used this same telescope for years, and today it's crashed on me. See here, it doesn't, it's some kind of error message.
Yeah. What happened is looks like ACP crashed on the computer in the observatory.
Wow.
Let me try to start it up again. I'm gonna hit. It doesn't look like the image finished processing. There we go. All right, now the image definitely did not succeed, even though it looked like it was on the camera. But so let's just try it again. That's all we can do, right? Maybe we'll get a guide star this time. Well, looks like the observatory computer needs a good restart. It's good to restart computers once in a while. See how we're doing here. Everything looks like it's running okay. Okay, now while that's running here, because we're going to have to get a new guide star and all that, let me give you the closing comments here. So, of course, if you are a member of the Kalamazoo Astronomical Society and pay the $50 remote telescope fee, which is good for basically the entire year, or basically the 9 months the telescope is actually online, and you live in one of the counties in red, you can actually use the remote telescope for your own personal imaging or even research projects. Again, you got to just pay your regular membership fee, additional $50 fee, which is nothing. If you've ever rented time on a commercial telescope, it costs more than $50 a day to rent a telescope like this, but we have a fee for a whole year. All right, there's that guide star again. Is it going to pick it? I don't care, but there we go. So of course, if you are joining us for the first time and you are not on the online viewing session email list, you can do just that right now. What you can do is use the chat to directly message me with your email address, or you can use our kas@kasonline.org email address, or you can go to our contact form, and there's a little pop-up option there to select the option that you want to join the online viewing session email list. Now, unless we do like a bonus session, there won't be any emails to the email list until probably October for the next season, because this is the last scheduled session of the season. But of course, there's many benefits here, or many reasons to sign up to the online viewing session email list. Now, if you are interested in astrophotography, you can join our next astrophotography SIG meeting. That'll be on February 17th. We will have a Zoom option if you can't join us in person, but there's a pretty good chance we might just hold the meeting via Zoom and not do it in person at Western Michigan University, because we've only done one in person this season for the SIG. And our very own Lloyd Simmons will give a little intro and demonstration to a free camera control program, telescope and camera control program called Nina. So if you're looking for a good program to control your telescope and mount and computer and don't want to spend any money on it, you can learn more about Nina on Friday, February 17th. Our co-host here, Kevin Jung, will put the registration link in the chat for you. And I highly recommend you check out our next general meeting on Friday, March 3rd at 7:00 p.m. That's Eastern Standard Time. All times here are Eastern. And that'll be both in person at the Kalamazoo Area Math and Science Center and also on Zoom. Our own local professional astronomer at Western, Dr. Kurt Kurista, will talk about Sir Arthur Stanley Eddington with stars in his eyes. You might be familiar with him because he observed the 1919 total solar eclipse. This is a reprocessed version of that eclipse because they had this massive prominence too. And of course, in about 2 months' time, we will start our in-person public observing sessions out at the Kalamazoo Nature Center. So if you do live in the Southwest Michigan area, you can join us at the Kalamazoo Nature Center in and around Owl Observatory. And of course, we're using the remote telescope tonight, but this is our other baby. This is the 16-inch Ashby telescope, which has a 4-inch teleview riding piggyback with an Astrophysics 1600 mount. So we do 2 sessions a month between April and October. And if we're lucky, we pull off about half of those. So when it's clear, you got to come out, because that is the time you actually get to see the sky. And I will probably show this to you again, but here is the link to download the images that we took tonight. Of course, you can't do it right now, but I will try to have the images processed for download probably tomorrow afternoon. But if things get hectic, it may not be till Monday. So don't harass me until late Monday or early Tuesday saying I can't download the images, because they might not be there yet. You got to give me a little bit of time. So if you're on the email list, either as a club member or online viewing session member or recipient, you already have this link in one of the emails I sent out recently. So just check your email for this link, but we'll put it in the chat. And if you're not on the email list or a member, you can copy and paste this into your notepad or whatever and save it for later, so you don't have to type all this down. Maybe I shouldn't just put it in the file folder, but, and by the way,
FYI, tomorrow
yes.
is Monday. Tomorrow
Oh, yeah.
is Monday.
I'm thinking, I'm thinking, yeah, because we usually do these on Saturday. I'm like a day behind now. Yeah. So I might have, so yeah, don't harass me until late Tuesday or early Wednesday. Everything changes by advances a day. All right. We're getting there. We're almost done, but I'll show this to you again if you want to write it down, or if you don't do the copy and paste thing in the chat there. But looks like we're doing good this time. No software crashes. And again, that's the first time in maybe 3-4 dozen viewing sessions that we've done where ACPs just crashed on us like that. But, you know, hey, it's software. It happens. At least it's not Windows 95. That's a really old joke. All right, we're almost there. So we're going a little past our allotted time there. We usually try to go about 2 hours, but because of our crash issue, we'll go a few minutes overtime. Kind of like the Super Bowl. Maybe they didn't go in overtime this year. I have no idea.
No, they didn't.
All right. Looks like, oh, and we did get a guide star this time too, so it was worth the wait. So the star images will be a little better quality than unguided. So things worked out for the best, I say. Ooh. Oh, now what's that? That's not supposed to be there. We're getting some reflection from something. Okay, well, that's not supposed to be there. But here we go. You can still see the galaxy, but this thing is not supposed to be there. Are we ready for our last target? Here we go.
Wow. I like that. Ooh.
Nice.
That's incredible.
Excellent.
Now again, this is probably from some light in the observatory. We've got to get Mike to cover up some of the lighting there. So we're getting some light there.
I think it's a balloon.
Yeah, it's a balloon. Yeah, that's right. It just exploded. I think I can see a faint F-22 right there that just shot it.
That's still
Actually, Richard, we've gotten that before shooting this object.
Have we? Okay.
Yeah.
Well, it's still low.
It's
All right,
still-
so
Hey, Andromeda gets their oxygen cloud. Maybe this is the one for M81.
Oh yeah. Yeah, maybe we made a discovery. I sort of doubt it though. That's pretty bright to not be discovered before. Okay, so this is a type SB spiral galaxy. There's, SAs, which have very tightly wound arms. SCs have very loose open arms. So this is kind of an intermediate in terms of its arm winding here. And it's also a grand design galaxy because it has two symmetrical spiral arms. And only about 10% of spirals are classified as grand design galaxies. Most have, branches and spurs, or they kind of have a woolly or flocculent appearance, but not this one. Two really pretty spiral arms. This galaxy is about 92,000 light years in diameter, and it contains at least 250 billion stars. So in many ways, that's very comparable to the Milky Way. But the nucleus, deep down in the heart of this galaxy, contains a 70 million solar mass black hole, a 70 million mass supermassive black hole, or 15 times the mass of the black hole in the Milky Way galaxy, which is just a little over 4 million solar masses. And this is 70 million solar masses. But it contains far less dark matter than the Milky Way. And unlike our galaxy, the rotation velocity decreases outwards, because that's how dark matter was discovered, as stars on the edge of our galaxy go a lot faster than that you would predict. So there must be unseen matter beyond the edge of the galaxy. And so this is the largest galaxy in the M81 group because it's M81. So we name it after the largest galaxy in its group. And so this group of galaxies has 34 members, which is a little bit smaller than the local group of galaxies, which contains the Milky Way. And this is the nearest galaxy cluster to the local group. Of course, you've heard of like the Virgo cluster, but the M81 group is a lot closer to us than the Virgo cluster of galaxies. And nearby, this is not it, by the way, but just 37 arc minutes away is M82. And that's the two galaxies are about 150,000 light years apart. The two pairs of galaxies interacted about a few 100 million years ago, and M81 looks pretty pristine, but M82 is kind of an edge-on but very disrupted starburst galaxy. What happens when galaxies pass near each other like this is the smaller galaxy perhaps gets very disturbed, the gas and dust gets all stirred up, and they go through huge bursts of star formation. But there isn't a terrible amount of star formation in M81. There is a lot, but not nearly as much as compared to M82 nearby. So there we go, our final official target of the night. So one last time, let me share the link to download tonight's images. And I want to thank you all for joining us for the final online viewing session of the season.